Good afternoon, everybody. Happy Thursday to you. I hope everyone is doing well. Let me take this time to welcome you to our webinar today on aquaculture production systems. We are so happy to have you on board today. Welcome Clay, Danson, and everybody else who is joining us on Zoom. And just FYI, we are also live on Facebook. So welcome if there's anyone logged in on Facebook right now. Yes. So today, thank you so much for sparing time in the course of your busy schedule to join us to this webinar today. So yes, just a big shout out to you. So on the comment section, we love to engage with you, and it would be great if we just get to interact with you, know where you're from, where you're tuning in from, be it Nairobi, Kisumu, wherever you are in part of Kenya. Yes, so a big thank you, a big welcome to you. So you can see the speakers for the day already in the house. That is Ivo and John Erick, whom I'll be introducing to you shortly. Yes, so welcome so much. On the comment section, just type one word where you're watching us from or where you're tuned in from. Here I am tuning in from Nairobi. Yes, so I'll just bring up my slides. John Erick, hi, how are you?
I'm good, Charity. How are you?
Good, good. Hi, Ivo.
Hi, Charity. How are you?
I'm good. You're well?
Thank you. Yes.
Yes, I know you're not in Kenya. Do you mind telling people where you are?
Yeah, I really live in Kenya, but I'm on a short family visit to the Netherlands where I'm from. So okay. I'm close to Amsterdam.
Awesome. Welcome so much, Clay from Mombasa, based in Siaya. I can see you, Elizabeth. Welcome from Thika. Kevin from Homa Bay, welcome. Oyo Kitengela, welcome, and everybody else. Yes, so this is Aquaculture Academy. We launched the Aquaculture Academy on 7th of May. So I believe some of you or a number of you were there. So yes, this is just an official welcome to you and a shout out on what we were able to launch. So the Aquaculture Academy pretty much provides a practical vocational training to just give me a minute on this. Yes, the Aquaculture Academy offers practical vocational training, and here it's all about commercial aquaculture. So we build and train aquapreneurs who will be able to run sustainable and profitable businesses, which pretty much has economic prosperity across the sector. So yes, in aquaculture, we offer 3 types of courses. So we have a basic aquaculture course, a 2-day basic aquaculture course, we have a 5-day advanced aquaculture course, and we have the mobile training option. And I'm sure Ivo will be feeding you with more information on all this at the end of the session. Yes, so our first speaker for today is here in the house. His name is John Erick. And John Erick is pretty much the project manager at Lattice Aqua. He did a Bachelor of Science in Fisheries and Aquaculture Management at University of Nairobi. He's an expert course. He actually did an expert course on aquaculture farming systems, and this he did focusing on RAS. He started managing the RAS demonstration farm in Kenya, that is between 2018 to 2020. And right now he's an international RAS consultant and currently pursuing a master's in limnology. I'm sure that is maybe a new term to some of you, but yes, he's pursuing a master's in limnology, and his current thesis on the efficiency of RAS in Kenya at Egerton University. Yes, so he works with Lattice Aqua right now as the project manager, and we're happy to have him on board. So welcome everybody who's joining us. We are happy to have you here. We look forward to having an engaging session. So just a bit of housekeeping before I welcome him on board. Please feel free to comment on the chat box, any questions that you have or any kind of questions, comments that you have even as the session goes on. We love your engagement. Yes, and just to introduce myself, my name is Charity Mbithe, the Communications Associate at Lattice. I'll be your moderator for the day. John Erick, welcome.
Thanks, Charity. I thought you were going to introduce Ivo.
I will introduce him.
Okay, so thanks a lot for that introduction and the welcoming. And on behalf of everyone on board, I would also just love to make you feel welcome, Charity. You welcome all of us now. Feel welcome yourself. I'm sure that all of us, if not, most of us, if not all of us, are in one way or another involved with fish. So more specifically, aquaculture. And that's why we are here today. So we want to talk about the production systems in aquaculture and also just get you to have a better feel of the Aquaculture Academy I know we launched on 7th May. We've been having these trainings on across the country. And so the training today is just, a free session just for you to get a feel of, what we've been doing. So aquaculture is very relevant, as you all know. That is in the supply of, cheap protein in Kenya, Sub-Saharan Africa, and even in the entire world right now. Over 50% of the fish we eat come from aquaculture. And I think, stakeholders in different aspects of governments are just starting to see how much we need aquaculture. And in Kenya, you can currently see a lot of activities going on, especially the ABDP. We're very, very happy with the progress being made. We saw the event last week. So for us, as Charity has said, our main aim is to ensure that there is enough practical skills that can enable the growth of commercial aquaculture in Kenya, to greater heights. And I just love to point out to 3 things that we are really considering in terms of aquaculture. So that is production. We have to ask ourselves as a country, as fish farmers, as students who are studying aquaculture, and even investors, that, how much fish are we producing? Looking at the report that FAO produced last year about the state of world fisheries, you realize that out of the 51 million metric tons of fish produced in inland aquaculture, 47.7 MMT of this is from Asia. So that leaves us with just 3 million metric tons to share around the entire rest of the world. Out of this 3 million, Africa only has 1.9 MMT. And just consider it a bit further, you realize that Egypt alone has 1.6 of this 1.9. So this leaves us with just 0.3 to share across the remaining 53 countries. So just looking at these figures, you realize that as a country and as a region, we are still lagging behind in terms of aquaculture production. Look at, for example, Kenya's per capita fish consumption. We're just still below 5 kilos. Comparing to the world average, which is, I think, at this point, passing 20 kilos, you realize there's still a lot of work that we need to do. So in terms of production, we have to ask ourselves, how much are we producing? And then as the Aquaculture Academy, as I said, commercial aquaculture will go to profitability. So we are producing X amount of fish, yes, but what level of profitability are we at? Everyone wants to make money. That's not a joke. It's very serious. We all want to make money. So out of the fish we're producing, how much money are we making from it? What is the business case out of all this? And lastly, we look at sustainability. We produce X amount of fish, we are at Y level of profitability, but then for how long can we do this? Is aquaculture something that was only relevant in the past? Do we need it now, or is it something for the future? You look at the reports of 1980s, people said aquaculture is the next big thing. You look at the reports in 1990, you realize that the same narrative was said, we need aquaculture for future proteins. We're in 2021, we shouldn't really be singing that song. We need aquaculture now just as much as we need it in the future. So production, profitability, and sustainability, those are our 3 main pillars in these trainings. And even as we look at this, we realize that we have to key in and look at the very nitty-gritties in production aspects. So we look at the species. Which fish species are we producing? Can it match these 3 criteria that I just mentioned? We look at the inputs such as feed. We look at the products that we are able to get out of this fish that we're producing, our business structures, our marketing strategies. And lastly, but obviously not the least, is our production systems. Because, whatever goals we set for ourselves in relation to the production that we want to achieve, the profitability levels that we desire as business people, and even the sustainability that we need, you realize that your cap is always set based on the production system that you go for. It determines your potential. So that's why today we are going to mainly talk about production systems. So feel free to ask questions. There's the chat section. We're also going to have a Q&A session. So I'll just go through this. So Charity, if you just take us to the first slide of the day.
Sure. Just a big shout out again to everyone that has just joined us in the last couple of seconds. Welcome to our Aquaculture Production Systems webinar. And Willie from Narok, hi. Yes, I'll go ahead and share the presentation generic. So please, like generic mentioned, feel free to go ahead and comment on the chat box, engage with us.
So I hope everyone can see the screen and the PowerPoint. So in green there, I'm saying that choosing the right culture system is the first step to success, right? Like I just explained, your potential is capped based on the production system that you go for. And remember, it is about commercial aquaculture. So the key indicators that as a fish farmer, when I want to set up my farm, I have to consider, one of them is productivity. So productivity in this case, remember I did talk about production. So production is the amount of fish you're producing in your farm. But then when I talk about productivity, I bring in the element of time to eat. So how much fish am I producing per unit area, per unit time? So based on your production goals, how much fish you want in a given period of time, you can already decide the kind of system that you want to use. You have to look at your maximum fish density. Because that is what is going to determine your stocking density. How many fish can you have in unit area of this system that you're going to? And because it's about commercialization, I brought in the element of power use because that is normally a major cost in certain systems. So in this case, we are looking at, the amount of power you're using to produce a kilo of fish, which at the end of the day, translates to the financial implications to your production cost. We look at the water use. How many liters do you need to produce a kilo of fish? It's something we have to start considering at this stage. And of course, you must all be familiar with the feed conversion ratio. We're just trying to look at the general efficiency of your inputs. How many kilos of feed, I did mention feed before, are you using to produce a kilo of fish? And that is going to determine on the production system that you have, the feed that you're using, the conditions that you're fishing, and of course, the survival rate. The system that you've decided to put in place, the species that you have, the conditions that you've given them, how many of the fish that you've stocked will you have on your harvesting date? And of course, we have different desires. And like I said, this is going to be determined by the production system. So the choice that you make will determine your survival rate. So I'm going to go through some of the production systems and you're going to see how this differ from one production system to the other. And one very important thing is in the level of investment. It's a question that, once you pitch the idea of aquaculture to most enthusiasts, the first question most of them will ask you is, how much money do I need to put up these systems? So in this case, I've just put up plus to plus, 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 plus. You can have your own different ways to categorize these investment levels. But then in this case, we'll use the pluses and you're going to see how it works from one production system to another. And then of course, we look at the control of the parameters. So we all know that every fish species has, given optimal conditions that they need. In our case, I know most of us do catfish and tilapia, or just tilapia, the latter alone. So in this case, the system that you put the fish, based on their optimal conditions, how much control do you have on your system? And again, to repeat the song, this is going to be determined by the production system that you choose. So Charity, just take us to the next slide. So like I said, we are going to look at ponds, we're going to look at cages, we're going to look at RAS. Those are the key production systems that we are, training people on in the Aquaculture Academy. So the open green pond, and I'm using the indicators I've just talked about before. So in productivity, these figures are based on the farmers we've been working with so far, the averages on a typical farm. We know there are farmers who are doing better than this. We know there are farmers who are not doing, their production levels are, to be, blunt enough, worse than these figures. But then these are the typical scenarios for, an open green pond. So the productivity in a pond, if you have an open green pond, like the ones you see in the pictures, it's normally from 0.3 to 0.5 kilos per square meter per year. So Maybe if you have more time, I could break it down how we arrived to these figures. The maximum density is usually 1 kilo per cubic meter. So this will determine how many fish you can have in your system. And this depends on certain factors, say, for example, your target size of fish, how many fish, what's the grams that you want to achieve at the end of your production cycle. For example, when I say the maximum density is 1 kilo per cubic meter, I mean that if you have a target of, say, 500 grams, then at any given point of time, you're only going to have 2 fish per cubic meter, because the 2 fish will amount to 1 kilogram. So you can do that math based on the size of your pond. So if I have a 300 square meter, my target weight is 500 grams, then I know that the maximum number of fish I can have in this pond, based on this maximum density, is 600 fish. If I have a production target of, say, 250 grams, that means that at the end of my production cycle, 1 cubic meter of my pond can have at most 4 fish. So you just do the math. In this case, the maximum goes to 1,200 fish. So the number of fish you stock will be based on your stocking densities, which are, of course, determined by the maximum density of your production system. So you have a choice to make: either go by this or have more fish, compromise your production a bit, that is, have a longer cycle length, or have less fish than this. And in that case, you're also, compromising an element of your business, because you are. So you can go either way of the scale. You can understock, you can have the optimum levels, or you can overstock. They all have implications. But then, from a technical point of view, we always advise farmers to consider these figures. The power use in an open green pond, as you can see from the picture, is 0. You don't need electricity to run this pond, unless you want to start, adding aeration and things like that, which, if you look at the spectrum of aquaculture production systems, it means that you're already moving from one system to another. But then for an open green pond, power use at this stage is 0. The water use, 5,000 liters for every kilo of fish you produce. I know most farmers just, pump in water, drain it out. Most don't even drain their ponds. Most don't even replace the water. But then if you consider a typical pond farm, operating in its full potential, you realize that you always need 5,000 liters to produce a kilo of fish. Most people may not know how we come to these figures. Again, if you have time, we may go deep into that. The feed conversion ratio, you can have a range of 1.6 to 2.1. Like I said, I know farmers who have figures of less than 1.6, and I also know farmers who have figures higher than 2.1. So this is a typical scenario. This is a typical pond farm, and based on actual data from farms. The survival rate is 65 to 85. The investment, in this case, I have 1+. You're going to see how that goes as you move up the spectrum of intensification. The control of parameters, in this case, it's just 1+. And again, you're going to see how that works. So in a nutshell, in an open green pond, fish are in a natural system with minimal input. So you're bringing in the feed, you're not controlling most of the production parameters. Charity, next slide. Yes, so this one is the cages. And I just did mention sustainability when I started this conversation earlier on. I said that in as much as we look at production profitability, we have to ask ourselves how long we want to do this. A bit of a concern, in the recent past has been the issue of sustainability, environmental concerns. And I say that in our local context where we have Lake Victoria, and I would say we are very lucky to have that, huge water body just here with us. I would say that we are far from overexploiting our system. The only thing is that maybe we didn't start off on a right foot because there was, not much information, and most people just went into the lake without knowing particulars of, what to consider, what not to do, what to do. So we need a lot of training around cages. Farmers need to know what to consider when siting their cages, because like I've said, we are yet to fully exploit our waters. Yet someone may say there's already a problem because we didn't start off on the right foot. So the productivity in cages, you can do 50 to 90 kilos per square meter per year. You compare that with a pond 0.3 to 0.5 in the initial slide, you already see the difference that comes in with intensification. The maximum density in this case is 40 kilos per cubic meter compared to what we had in ponds, which was just 1 kilo per cubic meter. So you can already use this maximum density number to work out how much fish you can stock in a single cage based on the size of the cage. And of course, it's normally a combination of so many factors that you have to consider. And the first one for a cage farm is where you have your cage. The power use, a typical cage farm, you have your cages in the water. At this point, it's still zero, just the same as in ponds. The water use in cages, 5,000 liters of water per kilo of fish produced. The question is, how do I know how much water I use to produce a kilo of fish in a cage? Because I have a cage in Lake Victoria, 67,000 square meters of water. How do I determine this? It's not that hard. It starts with the siting of your cage. You have to consider wave action. Normally they recommend 10 meter per second wave action. So if you look at the nitty-gritties, get it right from the start, then you know if I have this size of a cage, I have this amount of fish in the cage, I'm feeding this amount of feed, per production cycle, and this amount of, wave is passing through my cage, just the rate of water exchange, you can always determine how much water is used to produce a kilo of fish. And this, just trying to determine the sustainability of production systems, we always have to get these figures right. It may not be very relevant to a common farmer, but then as the trend setters, we have to know all this. The feed conversion ratio is starting to go down. Now we have 1.5 to 1.8. Again, my disclaimer, you may be out of this bracket, but this is the typical figure for a typical cage farmer. Then the survival rate starts from 65 to 90. It's a bit higher than in ponds. Then investment, now I have plus. You remember in ponds, we just had 1+. So these are significant increase in investment. It's significantly more expensive to set up a cage than to set up a pond. The control parameters, it's the same with ponds. There's not much you can control in the production environment, just the same in a pond as the same in a cage. The problems come in different names, but then they're just those same problems. The details, as you can see below, please locate your cage in the right depth. Consider the depth, the distance between the bottom of your cage and the bottom of the lake. The distance from the shore, there's normally a regulation with that. Ensure there's enough wave action when you site your cage. Charity, next slide. So this is now intensive RAS, ultimate intensification in aquaculture. So you see the huge difference. Now we are producing 100 to 125 kilos per square meter per year compared to 0.3 to 0.5 in a pond. We always joke in the aqua circles that, you can't compare these two systems. The maximum density is now 50. You realize that in cages we had 40, here it's 50. The power use, now we have a figure there, 2.5, compared to what we had in cages and ponds, which was 0. Again, the power use here for us will depend on your specific design. But then the 2.5 is for a typical RAS that's just following the basic recirculation design. That is 2.5. The water use has significantly gone down. In ponds and cages, we had 5,000, it's 500. So you see that huge difference. The FCR has significantly gone down. The survival rate has significantly gone up. And you look at the level of investment, that's where most people get blown off because here I have the full pluses. So it's significantly higher than cages. The control of parameters, again, is significantly higher than what we had in cages and ponds, because in a RAS, you have a closed system. You're controlling your environment. So the control of parameters is very high. So the key takeaway point in intensive RAS is that you have higher control of water quality and temperature. The productivity is very high, and there's the power use element to it. FCR is very low. Survival rate is very high. So those three production systems are the ones that, you know, we just decided to talk about today, because we know these are the systems that are commonly used in Kenya. RAS currently contributes around 3% of our production system. So it's still a work in progress. We know that people say it's something for the future. We hope that they are true. And ponds, of course, is the most common. Cages are just coming up and farmers are taking it up well. And we hope the legislations will work right. And all these are done in the Aquaculture Academy. So I just want to take us through a short guide that would help someone decide on what culture system to use based on the conditions in Kenya, considering the factors that, you know, we have to have in mind when we want to produce fish. And in this case, I'm majorly considering tilapia. So Charity just shows the next slide where we have a matrix. I hope you can see this from your end. It's a bit of some math. So say I meet someone today who wants to do fish farming, and this is in context of trying to choose a production system. My first question to this person would be, why do you want to start fish farm? Why do you want to get into fish farming? Do you want to do it for subsistence, or do you want to do it for commercial purposes? If you want to do it for subsistence, then you're really not, you know, a candidate of the trainings at the Aquaculture Academy, because we focus on commercial aquaculture. Charity, the screen went blank. I don't know if it's the same for everyone. Yeah, it's back. Thank you. So I was saying that for the subsistence farmers, they are not our target group, because our aim is with commercial aquaculture. But then for subsistence farming, I would always recommend just have a backyard pond close to your house that will suffice. Some people also want to have fish just for leisure, just ornamental fish. That's a different category. But then our main focus here is commercial. If your answer is commercial, then I would say, then select your choice based on the next questions. But then I said backyard ponds are for subsistence, but then you can also have traditional ponds or rest ponds in a greenhouse as something for subsistence use. If you say you want to do commercial, I'll ask you the next question, whether you have access to a large water body. If your answer is yes, we recommend cages. You need to do cages. So the main word here is access. Lake Victoria may be at your doorstep, but does that mean that you're allowed to use that point to grow fish? Does that mean that that particular location is suitable to put up cages? So this question, when you answer it, you have to be very, very keen before we recommend, you know, you put up cages. If your answer is yes, that indeed you have an access to large water body, then we move on to the next step and say, how accessible is that water body? Have you talked to the authorities that they allowed you to use that water body? And how suitable is that location for fish farming? So that is the next question that we ask. But then for the sake of, you know, making this table simpler, if your answer is yes, here we'll just recommend cages. Or if your answer is yes, we'll say that you could also do other systems inland near the water body. Say you dig a pond and use the water from the lake. That is also a choice. But then if you have no access to these large water bodies, and before I move to the next category, you may, large water body is not necessarily just Lake Victoria. We have several lakes in the country, and we have dams even in central Kenya, some in eastern Kenya, some in western. So I'm talking about a large water body in general, didn't just say a lake alone. But then if you don't have access to these large water bodies, then keep reading down, the table to see what might be most suitable for you. The next question would be, what is your planned capital investment? I just had that as an indicator when you're choosing a production system in the initial tables. So in this case, we have low investment levels, we have mid, we have high. So for low, in this case, it's less than 120,000 Kenya shillings. The mid is between Kenya shillings and 1.2 million. The high is above 1.2 million. And then I have points for each of them. We just recommend that you give yourself a score on the far right column based on your answer for this question. And then once we know what your level of investment is, how much you want to put into this venture, we ask yourself, what is the size of your land? Remember, we are already done with those who have access to large water bodies. So we already know that you want to do inland farming. Then what is the size of your land? So this could be land that you already own, or land that you plan to purchase for the purpose of fish farming. So in this case, we have small land. This one I characterized it with being less than 400 square meters. Mid is 400 to 1,000, and large is above 1,000 square meters. Again, give yourself a score. You're going to have a total at the end, and the totals will direct you to the farming system. Once we look at the size of your land, we ask you what is the rate of water availability in your location, because you can't think about fish without water. So how much water do you think is in your disposal per day if you had set up a fish farm in your location, the land that we just talked about? So the characteristic of low rate is 8,000 liters per day. That is 8 cubic meters. Mid is from 8 to 20 cubic meters per day. High is above 80 cubic meters per day. So again, we have points. You just give yourself a score. And then we look at the technical production side of it, where we look at the temperature. How is the temperature like in your region? Are you below 22 degrees centigrade? Are you in the mid region where it's 22 to 25? Or are your temperatures above 26 degrees Celsius? We have to ask this because if you've been into fish farming, then you ought to know that temperature is a very, very important factor to consider in your production. If you are just planning to set up a farm, then you just got the news. Temperature is something that you have to consider. So that's why we have the points. So again, give yourself your marks. Then, of course, it's a business. You can't set up a business without your end market in your mind. You have to think before setting up a farm. Where do you want to sell the fish that I want to produce? So you start thinking from the market going backwards. And what is the distance between this site that you want to put up for aquaculture and your potential market? So we have close, we have mid, we have far. Again, there are characteristics. Less than 20 kilometers, that market is close to your farm. Mid is 20 to 50. A market that's far from you is more than 50 kilometers away. And for this question, it's not just the market, the distance between the market and the site. You also need to ask yourself, what is my desire? Do I want to grow fish closer to the market, or do I not care about that? If you care about that, then you can already figure out what you can produce or the system you can use. Because, for example, if I say I want to sell fish in Nairobi, you can't go do cages in Lake Victoria if your desire was to grow fish close to the market. So in this case, your market is Nairobi. The cages are set up in Lake Victoria. That's the only large water body that you have access to. And your desire is to have your farm close to the market. There's already a discrepancy. So that already will tell you that the system I'll need to achieve the desire of having my farm close to the market, which is Nairobi in this case, you'll need to opt for a different system. Do I want to have Kisumu as my market? I can do cages, I'm close to Kisumu. So it depends on your desires. Someone may say that I want to have Nairobi as my market, but I don't, care about the distance. Again, you give yourself the points, and that will lead you to a choice. Now, I said power use is very important. So what is the condition of electricity supply in your area? Is it stable? Is it mid? Is it low? I have been to regions where out of the 7 days, you have power 2 out of the 7. I've been to regions where you never experience a blackout in two months in a row. So I know that, power stability and even access to power itself, it's fragmented across the country. There are those who have more access than the others. There are those who are more, have more stable powers. So just look at the site that you want to set up your farm. You know it better, and see whether it's stable, it's mid, or unstable. Give yourself the points. It's here. At the end of the day, your sum will give you something. And what quality of feed are you able to and or willing to purchase? So we look at the quality of the feed. You can use, a combination of algae and homemade feed. In this case, your crude protein is going to be less than 28%. Your price is going to be less than 90 shillings per kilo. But then your FCR is going to be slightly higher, 1.8 to 2.2. You give yourself a point. You look at the mid level in terms of the quality of the feed. You can buy feed that's, not expensive, but then the crude protein is low. You look at the FCR levels, better than the homemade feed, but then it's the mid level. It's not the ultimate high quality feed, high energy. So the last stage is the price per kilo is over 120, the FCR is 1.3, the crude protein is over 32%. It's your choice. So I'm giving you a price range, I'm giving you, the quality indicators, and then you tell us, what are you willing to buy when you set up the farm? Or if you already have a farm, what are you willing to buy? Then you give yourself a point based on that. Still on the inputs, you look at the fingerlings. There's the low quality, there's the mid, there's the high. So for the low quality, anything that is less than 5 grams, most of us don't like calling them fingerlings because that's not really fingerlings. They are fries at 3 shillings or 10 shillings, 3 to 10 shillings per piece. That is the low quality. Of course, the survival rate of such fish. The mid level is 5 grams to say 15 grams, 10 to 20 shillings. You give yourself points. The high quality, 15 grams to 30 grams, 25 shillings to 30 shillings. Of course, that's the right fingerling size, but then we know our constraints as, in our local sector, most farmers will buy these small fingerlings, 5 grams. Some even do less than the 5 grams. It's a constraint in our input supply sector. But then you want to get into fish farming, ask yourself, what quality will you be going for? Give yourself these points. So when you add your points, you're going to have a scoreboard just below that table. I don't know if Charity, you could scroll a bit up so that the table is a bit clear. Or just leave it that way, it's fine. So you'll see your best choice. Your open green pond is always the lowest points. You can have a greenhouse pond. You can have an aerated pond. You can have IPRS, in-pond raceway systems, or you can have RAS scoring the highest points. So if you have this table, it's not the ultimate guide to getting the most suitable production system, but at least it asks you the key questions that you need to know. It points you to the main considerations in these indicators to consider in choosing a production system. What do I really need to look into? So if you look at the feed, you look at the differences in prices, the differences in crude protein percentages, the differences in potential FCR. You look at the fingerlings, you look at the price differences, you look at the different sizes, and of course, you can even know the survival rates of different sizes of the fingerlings. So at the end of the day, you can be able to choose the best system that can work for you based on your local conditions. So I'll ask Charity to just play just one video, because we also have an e-curriculum, which Ivo will talk about. So Charity, please play that video, where you can just see an illustration of one of the production systems that we are talking about.
In pond farming, tilapia is raised in concrete, liner or earthen ponds. Pond farms require a lot of water and should be situated near rivers or other water bodies. In addition, ponds are an open water farming system and rely on the temperature of the area, and should therefore only be located in areas with a year-round temperature of above 25 degrees Celsius. If seasonal temperatures go below this temperature, a farmer should consider not stocking their ponds during the months with low temperatures, or consider installation of a greenhouse cover over the pond to keep the temperatures high and constant. In pond systems, natural food consisting of phytoplankton and zooplankton will contribute to the total feed consumed by tilapia. The required additional feeding depends on the intensity of production and whether paddle wheels for additional aeration are present. A key challenge in pond farming is managing water quality. Oxygen levels in ponds can lower quickly as a result of large fish biomass and also the presence of oxygen-consuming microalgae in the pond. As oxygen levels are generally lower in the morning, the appetite of the fish is usually also lower during this time. Overfeeding in ponds can have a negative effect on water quality, causing nitrite and ammonium levels to spike and oxygen levels to drop. Proper feed and water quality monitoring are thus essential in pond farming. The level of investment needed to start pond farming can differ strongly as a result of the construction materials chosen. Concrete ponds are more expensive than earthen ponds. If the soil consists of a minimum of 30% clay, you have the possibility to construct an earthen pond. More sandy soils will lead to water seeping through and require the use of pond liner. Aeration and other forms of water quality control increase the investment costs but benefit the overall production efficiency. Stocking densities in extensive conditions are limited to 1 or 2 fish per square metre. Intensive farms with continuous aeration can stock up to 5 tilapia per square metre. In order to be profitable in fish farming, scale of production and constant supply to the market are key. It is therefore advised to collaborate with other fish farmers to be able to deliver consistently to the market and get food equipment at a better price.
Thanks, Charity. I'll just give the mic back to you. You're on mute.
Thank you so much, Erick, for your amazing presentation. I've been able to learn so much as well. I hope the attendees have. That was Erick with the Aquaculture Production Systems presentation. Thank you, Victor, for your comment. Wow, that was really awesome. Yes. So it was just giving some guidelines on the ponds, cages, and the rust, as well as the selection guide. So the next speaker that I'm about to introduce to you is Ivo van der Lee. I don't know if you, Ivo, help me by mentioning your name well.
Van der Lee, you're close.
All right, yes. So Ivo is a master's degree student, or rather a graduate in master's. He did a master's degree rather in aquaculture and marine resource management from Wageningen University and Research Center. After his master's, he's worked with ASA Ethiopia, and here the first commercial fish farm in the country. He was able to work on that, and he was in charge of more than 50 staff members, and here he trained them in all the essential steps of fish farming. And further, he has been able to manage the fund's research program and assisted Alemacodids in operating the first extrusion line in the country. And then after that, we worked with NABC, focusing on market studies with agribusiness sector, and organized 2 trade missions. And now he's the technical project manager for Lattice Aqua. Ivo, over to you. Welcome.
Thank you very much, Charity. And also thank you very much, Erick, for the nice presentation before. So what I want to do is I want to take a step back to the video that we just saw. This video is part of the e-curriculum that we developed with Lattice Aqua, together with our partner Lattice International, the Netherlands, together with Skretting, the feed producer, and together with Blue Planet, based in Norway. So the reason why we also developed an e-curriculum besides Aquaculture Academy is because we know that for some farmers, some people working in the sector, they live in more isolated regions, and it can be really difficult to attend a training or to meet other people that work in the same sector. So by having this e-curriculum, we can provide information to anyone who has an internet access, so they can educate themselves and they can get knowledge that might be missing, or tips on subjects they might be struggling with. So we currently have about 60 videos. Part of them are production systems. That's what Erick just showed, but we have much more topics related to aquaculture. So we have topics on hatchery, production systems, on genetics, on reproduction, on stock keeping, sales and marketing, basically everything that you need to produce fish. Further, we have quite a number of videos on nutrition. That's where Skretting came in very generously to help us with the videos. So we have videos about nutrition in different life stages of the fish. We have videos on feed production, on raw material selection, on novel raw material selection. So it really can give a nice overview for a farmer to improve their farming skills. Charity, I don't see my PowerPoint yet. Is it coming up?
That's why you make the request, and that's why I bring it up.
Sorry, okay, then we missed there. I thought it was loading, but I'm sure the summary will come up nice. And I just continue my story for now. So the good thing about this e-curriculum is that it's available for free. There is a link in the PowerPoint presentation that will be uploaded right now. You can access it, you can make an account for free, and after that you can freely upload, freely look at the videos, and see what how they can help you. The difference, however, with the e-curriculum and the Aquaculture Academy is that we all know fish farming is not just theoretical information. It's really about how can you apply the information that you just learned. So example, the presentation from Erick, and how can you apply it in the field? How do you make decisions based on your theoretical background? And that's why practical experience and vocational training is so important. Can we go to the next slide, Charity? Oh, yeah, that's why it's so important. So because of that, we have Aquaculture Academy, and during Aquaculture Academy, you have several courses. And what we do, we train people on farms that are already in production. So you get the theoretical knowledge that's a bit more in-depth as how we have it in the e-curriculum, but we really teach you how to apply it in the fields and how do you really get the skills needed to farm fish. Well, in order to do that, as I said, we have 2 farms that we partnered with that are already in production, and where we can teach on their farm. So you really get to see how a functioning farm works and how you can and what skills are needed to work there. So the first one is Kamutanga Fish Farm. Kamutanga is based in Machakos. It's established together in partnership with Foodtech Africa, and it has a high-tech RAS technology. It means they use high-tech equipment, land-based, it's very new. Further, they have a high-tech hatchery as well, and they use YY technology, which means they are able to produce monosex tilapia without the use of artificial hormones. Well, the first one to receive the EcoMark label, and they have many facilities and already experience with training, so it's a good partner for us to really teach people how to work with this high technology. But rather than me speaking more, I would like to show a short video of how the farm looks like. Charity, can we start that?
put together by Kamudanga and Foodtech Africa. My name is Anthony Mbithe, and I'm a director of Kamudanga Farm. Kamudanga Farm is an aquaculture farm that has been put together by Kamudanga and Foodtech Africa. Foodtech Africa came in with the knowledge and technology, and Foodtech Africa have been able to transfer this to Kamudanga Farm in a very successful way. You know, they basically took us through the whole route of how to fish farm, you know, in a very intensive way. And this also led to the introduction of the recirculatory system, which is basically still new to this part of our world. And Foodtech Africa was also able to impart knowledge and the technology to Kamudanga Farm, you know, on how to use the recirculatory system to fish farm. The recirculatory system is basically where you recirculate your water 24 hours in a day. It helps you conserve water, and it helps in the production of fish in a very limited area where you can produce fish very, very, you know, intensively. An aquaculture academy will be introduced here on Kamudanga Farm. And the Aquaculture Academy will train trainees on fish production. This is from egg to plate. And this will also put them in touch with learning how to run the recirculatory system and teaching them what the recirculatory system is. It's a very intensive way to farm. So one will need to know exactly how to run the recirculatory system. So all trainees will have the benefit of learning the whole process and actually working with the employees of Kamudanga Farm on a day-to-day basis of you know, handling it, you know, on a practical basis.
Thank you very much, Charity. So as I mentioned, besides Kamudanga, we have a second farm that we partner with. Maybe Charity, you can show the PowerPoint for Juliet. So the next farm is Juliet. They're based in Homa Bay. And they are for many years in operation. They have a high production, and they do this with a more common system, so pond farming and cage farming. Besides that, they still have a high-tech a high-tech hatchery. Previous one. Yeah, they still have a high-tech hatchery in ponds, and they still use incubators. And what's the difference again with Kamudanga is that they use sex reversal instead of YY. So it allows us to train on different techniques. They have an impressive breeding program, so really pioneer in several parts of the production. And also they have for many years experience with training students. So we can, they're happy to receive us with our trainees to show, to teach them their knowledge and also mostly their practical skills. Also, we have a video of Juliet. Maybe Charity, can you start that one?
I'm Enos Were, the founder and a managing director of the Juliet Enterprises. Juliet, we have 5 farms, 4 land-based farm, and this one which is water-based, where we have the cages. We started fish farming in 2010 with 4 ponds in 1.5 acre farm. And in the cage farm, now we have 25 big cages with a capacity of 17 tons, where we do selective breeding. Aquaculture, one, has been well-paying. We've seen quite a bit of growth from 2010 to where we are today, 11 years down the line. To me, the biggest challenge of in aquaculture in Africa is training. We don't have hands-on training, people who can manage fish farms. In sub-Saharan Africa, it's still in its infant stages. And that means what many people are used to is the subsistence fish farming. So people don't have the experience, and therefore we've been ill-equipped to have people who can manage commercial fish farms. My first time Food Tech Africa, John Erick giving me a call, and they learned that Juliet is one of the commercial fish farming enterprise. Then they told me about their intention to have a training for commercial fish farmers. I've always believed in vocational training, where people are hands-on, because that would capture all cadre of farmers or all cadre of extension officers, irrespective of their level of education. So when they explained to me they wanted that practical training, I bought into it. I would advise people to come and experience the unique training. You can hardly go wrong when you learn to grow 1 ton of fish with people who grow 100 tons of fish. We also have a hatchery, which is a state-of-art hatchery, where we are doing incubation of eggs, hatching them, sex reversing them. That will also be physical. In all those points, one, we have a resource center next to our hatchery. In the live fish center, we are also putting in some structures and tents where we can get people can be trained.
Thank you, Charity. Can you put the PowerPoint ready again? Make the PowerPoint ready. So before going into PowerPoint, because I want to tell a bit about the courses that we offer in Aquaculture Academy. But before that, I want to clarify something. So as we told, now we have 2 different campuses, one in Machakos, Kamutanga, and one in Juliet in Homa Bay. But what we hope is that our trainees, they don't select the farm based on the distance from their home. As you can see in the videos, both farms, they are different. They use different production systems. One uses YY broodstock, the other one uses sex reversal. And what we want to stress to the potential trainees is please look at what's useful for you. If you're a farmer and you really want to focus on pond farming, then really the best place for you is to go to Juliet, because they have ponds. We can teach you practical skills on pond farming. However, if you're an extension worker that says, I want to get to know high-tech RAS facilities, I want to use how YY broodstock use in reality, then please select Kamutanga. So the added benefit of these practical skills is really how you can apply it in your own situation. So please, think about that before selecting a campus. Well, then we go in the courses itself. So Aquaculture Academy offers 3 courses, a basic course, an advanced course, and a mobile training. And I'm very briefly going to go through them. So can we go to the next slide? So first we have the basic course. The basic course takes 2 days, and it's really more meant as an introduction to fish farming. People can get, some theoretical knowledge about factors that are important to know when you start farm fish. They get to see practical work on the farm. They get to experience it by assisting in the work. So they really see what it takes to manage a farm and how it's done. And therefore, it's very suitable for people that want to consider starting a farm. So they have a bit of an introduction, or extension workers that don't directly work on a farm, but do work it on a day-to-day basis, so they understand what's going on. While the advanced course, so next slide, please. The advanced course takes 5 days. And of course, we're going to go a bit more in depth in the theory as well, so we can teach more subjects. But what's more important is that we're also going to spend more time on the farm itself, which means you don't just get to assist in farming, you really get to taught how to do these skills independently, which means that by the time you leave the course, you can do these jobs by yourself. So at the farm you're working in, at the start you're farming, you know what to do yourself. So it's really about teaching you these practical skills to work independently. And then lastly, we have our mobile unit. So next slide, please. So the mobile unit, as you can see in the presentation, I hope, is a van. The van is equipped with, of course, training material, so we can train in all remote locations. But it's also equipped with a large number of water quality testing material, which means we can do thorough water quality analysis anywhere in the country, which allows us to train large group of people. So that's the big advantage. We can come to a farm, we can measure water, we can see the local circumstances and really train people on the farm they're actually working in. or we can go to groups of people and give them tailor-made training on the location what they are. So this means that we can come to you instead of you come to us, which makes it especially suitable for large groups. Well, there's a few more details to the training, so then I want to give the word back to Charity.
Thank you so much, Ivo, for the amazing presentation that has been Ivo on the online curriculum, as well as the Aquaculture Academy campuses, that is Kamudanga and Gillette, and the courses that we offer. So for the 2-day basic course, I'll pick up on the pricing. We offer a 2-day basic course at both academies, that is at Gillette Fish Farm and at Kamudanga Fish Farm. The 2-day basic Aquaculture Academy course goes for 5,000 Kenyan shillings, while the 5-day advanced Aquaculture Academy course goes for 10,000 shillings. The last course that Ivo just mentioned about the mobile training, that one session goes for 63,000 shillings, and the payment details are on your screen. So what you can do is you can take a quick screenshot just to refer to this later on if you want to make a payment. So you can make 50% payment prior to the course, and then once you're able to, once the course is administered to you, then you can be able to finalize the courses. Yes, so we definitely want to be, want you to see in class, and even as you grow to be those successful aquaculture entrepreneurs. So just to answer some queries I've seen on the chat box, please drop down, first of all, please drop down all the questions that you have regarding the aquaculture production systems and the topics that have been discussed today. Just to answer your queries, yes, I'll be sharing the presentation as, on my follow-up email, so please watch out for that, as well as all the details regarding the Aquaculture Academy courses and the prizes. So please feel free to enroll. We have our first intake. Let me just open that slide. Yes, our intake starts on 9th to 13th August 2021. That is in about a month's time. So it would be great if you join us. We have 2 campuses, the basic and advanced courses. So once you go sit down and think about which one applies to you, even from the Erick selection guide, please reach out to us via the contact details on your screen. Feel free to screenshot that and just get back to me. If you have any queries, I'm the one who invited you to the webinar, so just respond to my email and ask me any kind of queries regarding the Aquaculture Academy. Yes, so for the people asking for a recording, this webinar was live on Facebook at Lattice Aquaculture. So just go there, go on Facebook and search for Lattice Aquaculture, follow us, like us, and you'll be able to access the webinar as well. Yes, so Erick and Ivo, there are a number of questions that have come up. So before I forget, you can also check out our website, www.aquacultureacademy.co.ke. Yes, very informative session. I'm seeing all those comments from attendees. Thank you so much, Erick and Ivo. That was awesome. Yes, so let me just scroll up to read one of the questions. So,
hello, Charity.
Yes, hi, how are you?
I'm fine. I'm very happy for the invitation.
Yeah.
I have one question. Are they both ready to work with the already formed farmer business schools? We have
sorry?
like where I'm coming from. Already we have a Aquaculture farmer business school. Are they ready to work with us?
I'll just direct that to Erick. Erick, please go ahead and respond.
Joshua, yes, we are very, very open to collaborations, and we are trying to look at it from an ecosystem point of view. We can't solve our problems in a standalone ecosystem. So just drop your email or your phone number. Charity can give you our contacts, and then let's have that conversation after this training.
Okay, thank you so much, Erick. Kimutai, I'm seeing your question. Can I be part of the trainees in your academy? I did BC in fisheries and something. Yes, I'll get back to you on that. So thank you so much for all the queries, because I'm seeing you're already out of time. I'll be able to respond to you on email, and so that we can ensure that we've captured everybody's question. Feel free to, I'll reach out to you on email just with all the responses. Yes. So can we get certificates to this webinar? For now, no, but once you join the academy, you'll be able to get a certificate for the course that you'll be able to take. Please keep your questions coming. And don't forget that our training dates are from 9th to 13th August. So I'm also seeing a request that we should start an aquaculture academy in Democratic Republic of Congo. Yes, we are coming, but for now we're in Kenya. We hope to, expand soon as we go by. Yes. Any other person with a question?
Hi, Charity.
Hi.
Yeah, this is Victor from Siaya. I just had a concern. We're also working on we have a consultancy agency that is called Vijana Aquatic Blue. And I'm very much impressed by what's going on here about the academy, and would also like to be part of this as an agency.
So we'll get back to you on that as well. So just email me back and let me know all those details, and then we'll get back to you. There's one question from Ferdinand Oranger, and I can direct this maybe to Ivo. Kindly explain the advantages of the cage production system over the pond system. Kindly explain the advantages of the cage production system over the pond system.
Thank you, Chad. So what John Erick just mentioned in the selection tool that he presented is that for cages, of course, you need a large water body. That's the first step in that selection tool, which means it's one of the advantages is where you can have it. So ponds, you can do land-based. If you have access to a lake, you can do cages. Of course, there's a bit more advantages and disadvantages. So as John Erick mentioned, like if an earthen pond, so the most simple variety, so to say, it is less investment than a cage. Then again, in a cage, you can do a larger amount of fish. You can have a higher stocking density, so you can have a higher production. So what I would advise, those are the main things, but please go to the selection tool. We'll send it after the presentation, and then you really have a nice list of the advantages and disadvantages of cage and pond. Please note that also in ponds, we now focused on green ponds. Also ponds you can more intensify, so you can do intensive production in ponds. Also then, of course, you have more investment, but also you can increase stocking density and your increase stocks and increase your production. So there's many options to go to.
All right, thank you so much. There's another question from Victor. Maybe John Erick, you want to address this? Kindly explain further about water use in both cages and ponds. Maybe some more comments about water use in ponds and cages. John Erick?
So normally, when you feed your fish, there's what comes out as waste. So part of the feed, as you expect, should be used to form the fish biomass. But then just like in us, some of it is excreted, and this forms, waste in the water. So this is the bulk of, the waste that you need to be replacing with the new water. So normally when you do the calculations, you look at how much water, clean water, do you need to add to your system as a response to the amount of feed that you put in your system. So what differs with these systems is that, the efficiency of the input differs. With the amount of feed going in a cage, sometimes most of that feed gets converted into a biomass because of, good water exchange. And so you realize that you may need less water to replace the waste that has been created by the feed that has not been, ingested, as compared to a pond, where the water exchange is not, very high. So it means that for you to actually counter the effect of the waste produced from feeding your fish, you need to be adding in water. But then most people in ponds don't replace water that often, because replacing water that often in a system that you don't control, say, for example, temperatures, new water, most cases, comes in with less temperatures, and you don't want to be compromising that. So you realize that we compromise productivity because of the system that we have. So that's why I was saying that your potential in production is determined by your production system. So the biggest, change, distinction can be seen between the two systems in RAS, where I say that for every kilo of feed you put in, you need only 500 liters of fresh water. because you're recirculating over 90% of, the total volume. So the amount of feed that you put in your system will determine the amount of fresh water that you put in your system. So to have optimal production, you need to put in feed frequently. That is considering the demand of your fish. So putting in feed you need to replace water. So if you do that sum and figure out how much water you put in at the end of the day, you realize that for pond and cages, at the end of the day, you need around 5,000 liters to counter that effect of the wastage.
Okay, thank you so much for for the answer, John Erick. I think that's very clear. Victor, I hope that's satisfactory. Just one final follow-up question from Victor. You mentioned that the frequency that the water needs to be replaced in ponds. So maybe is there a timeline to it? Victor is asking, how frequent do we need to replace water in the ponds?
So like I said, it depends on the amount of feed you put in your system, and the amount of feed depends on the demand of your fish. So it's a combination of so many factors. It's a lattice, like the name of our company. So it's so many factors that you have to consider. Look at how much feed you're putting into your system, calculate the cumulative feed that you've given, say, in a week, what's the volume of your pond, and come up with the rate for yourself. So if you say that for every kilo of feed that I'm putting in my system, I need this and this amount of fresh water, then you put a cap. Once you get to that amount of feed, cumulative feed, replace that water. So for optimal production in a pond, you need 5,000 liters for every kilo of feed. So do the math, relate, and exchange when necessary. It may be difficult because of access to water or the fear to compromise other production parameters such as temperature, but then that is what is required.
All right, thank you so much, John Erick. Thank you, Ivo. Our speakers for the day have been Ivo and John Erick. Ivo is the technical project manager at Lattice Aqua, and John Erick is the project manager at Lattice Aqua. I've been your moderator for the day, Charity Mbithe, the communications associate at Lattice, and we look forward to you joining us in the Aquaculture Academy. The details are still on screen. The next intake begins on 9th to 13th of August. Contact us, call us, WhatsApp us via the number on your screen, email me back, and follow us on our social media, Lattice Aquaculture. If you missed any part of this webinar, feel free to go on Facebook at Lattice Aquaculture and just rewind and catch back on what you've been able to miss out on. Yes, so for now, bye for now. Thank you so much for sparing time. We look forward to engaging with you and actually seeing you at the Aquaculture Academy. So if you want to join us, the details are on your screen as well, the payment details, both for basic, for advanced, and for the mobile training with the pay bill number and the bank account details. All right, see you then. Until then, God bless you and keep safe.
Hello, Charity, please.
Because we're running out of time, please just email me and then I'll be able to, get back to you because we are really against time.
Okay, thank you.
All right. Bye, everybody.